Hey friends, good evening everyone, and hope you're doing great. Um, of late, the climate has changed a little, and right, it's been raining in some parts of the country, southern India. So yeah, hope everybody is safe and sound and taking precautions. Um, Let me start the session for the day. As part of the series of deployment of machine learning models, we did cover a few concepts. And today we are going to talk about how do we use Google Cloud Platform. And we are going to try and understand how we can scale up or scale down automatically using the Kubernetes service, which is readily available in Google. We are going to use GKE, that is Google Kubernetes Engine. It's a service which is a combination of the open source Kubernetes service and on the Google platform. So it's a self-managed Kubernetes engine, which automatically looks at the entire machine learning model requirements. It pulls up all the required resources. It will ensure that high availability and scalability are maintained. It also has storage capacity, right? So there are a bunch of benefits that the GKE service is going to offer. So we are going to take the advantage, leverage on this service, and we will implement a machine learning model with UI on the resources of Google platform, thanks to GKE. Now, let me just do a quick revision or roundabout on all the concepts that we have discussed till now as part of the series. So if you remember the very beginning of the series, we started understanding how the deployment needs to be done for a machine learning model. So we are talking about an ML model. For ease of understanding, we are sticking to a single model for the entire discussion of various tools and techniques that we have in these series. And the first video of this series, we were discussing about the machine learning model, which is multiple linear regression that we used in predicting the fuel efficiency. And we tried to do the local deployment. Even before we talk about deployment, we need to try and define the pipelines. And these pipelines can be of two broad segments. One is the data pre-processing pipelines. So I will say data pre-processing. And then the other one is the machine learning model, which uses hyperparameter tuning optimization techniques embedded in it. Predominantly AutoML techniques would be used, but for our discussion, we have used a single model, which is multiple linear regression. So once these pipelines are defined, the flow is saved in these models. We will take those saved models, right? We save the models and we take those saved models and we try to embed that, integrate with some kind of a web UI. So that as an end user, we will have an interface like HTML page, which can allow non-programmers, customers to utilize the functionality of the machine learning model that we are trying to develop. So two major things. One is your ML code, which is given in saved models, that is your trained and evaluated best model is saved, and we can save it using joblib or pickle libraries. The trained algorithm gets saved. Plus, along with this, we will have to try and write some code which basically allows us to have the UI. Now, we are not software engineers, right? So we are basically data scientists. So we need to try and have our code developed in such a way that it is easy for us to understand in the same lines of machine learning code, Python. right? So we will try and use Python programming language itself to develop this UI. And in order to do that, we discussed that there are three different types of web frameworks which can be utilized. The first one is Flask, and this is my personal favorite, which is a micro web framework library. And we also have Fast API. This is also a very small web framework, and this is the latest one, and it is fast catching up. It is considered to be super fast. And then the full stack web framework. These are the popular three, right? And I always talk about these three, and in the data science community, we generally use these three platforms for getting us a HTML-based UI, user interface, a web page. The beauty of these libraries is that they automatically render the HTML code that is written to give us the UI. And these HTML codes, you don't have to really write it from scratch. A lot of readily available templates can be used. And thanks to the open source nature of our entire data science community, a lot of readily available code for all the algorithms are there. You just take it up, make the subtle changes which you want to bring in your UI, especially with respect to the data fields that you want to ask as an input, etc. The look and feel, the colors, the image, background images. So those are some of the background changes that you might want to do here. And then embed the saved models in this particular HTML code, a Flask code, you should say. So it is going to try and embed this and this together and give us the UI. This is the first concept that we discussed with respect to the deployment logic. And then we try to use our local machine to implement this particular entire ML code. Post that, we talked about Heroku, which is a cloud-based PaaS service, cloud service. It's basically a platform where it gives you the instances where you can try and put your code, the Flask code along with your machine learning code, so that you will be able to access that particular functionality anywhere from the world, right? So it is publicly accessible service. And in the interim, we also talked about how important Git repositories are, the code repositories. And we discussed about GitHub, which is the most popular one, but we can also use the other Git buckets. We can have various different repository hubs that we can try and pick up. This is very, very popular in the world. So all this code that we are developing will sit here so that we can have continuous development of the code by different people in different modules that we are trying to develop in machine learning model. So you don't need to do the offline development and then push it. You can have that repository where multiple users can contribute, and you'll always have the latest of the code available for your usage, software development usage, operations usage. So this is the code repository. We've also discussed about this. Then you need to remember that from December 1st, 2022, Heroku has stopped free service. No free service anymore. So if you are fond of Heroku, a lot of people are fond of Heroku. I'm one of them. It's a very, very interesting platform and very useful platform for a lot of newbies, especially the data science community. But unfortunately, they have stopped the free services. Here, we will be using any of these frameworks and then pushing the code into the server. Right? This is something that we have done. Then we have also talked about Streamlit. Streamlit is again a platform which also has HTML embedding within it. So you don't have to write HTML templates separately. You don't need to have HTML code separately written. We can just write our Streamlit code, which tries to embed the saved models within that particular readily available various functions in Streamlit. And thanks to this readily available widgets, Streamlit is going to develop the HTML pages on itself, and then it also going to place the application on the freely available cloud platform within Streamlit public access. So this is also something that we have done. Post that, right? These are all open source tools. Post that, we talked about how do you deploy a machine learning model on cloud platforms, right? And when we talk about cloud platforms, the most popular one being AWS. Here, we used a specific service called Beanstalk, which is used for deploying your machine learning models. Then in the previous session, we used Azure services, Microsoft Azure services. And here we used Azure Kubernetes Service. We call it as AKS. On the same lines of AKS, we are going to try and use Google Kubernetes Engine. Now, the advantages of these Beanstalk or Kubernetes engines that we're talking about are that they ensure that your application is always available. So we will have high availability. Then we have scalability, right? We'll have automatic monitoring, right? Version tracking. We will be able to capture the drift in the models and in the data, of course. And we also have an advantage with respect to single storage point of right location. All these are self-managed, right? That is another advantage, self-managed. And in order to ensure that these services are available, the application that we are developing, ML plus Flask application, for example, is going to be containerized. So we are creating an image of this code, static image kind of a code. We write, we Dockerize this. That means we containerize this using the software called Docker. And this image is made publicly available, or is basically available to the respective end users who want to consume it, either publicly made available or using some private credentials. We try to restrict it. Restricted access is given to the images, and these images that we create here, the image is getting deployed. Right? When I say deployed, basically is containerizing the image. So it becomes a runtime instance, right? So this image is getting generated as a runtime instance. And this is done using a Kubernetes engine. To start with, Kubernetes engine is an open source software which was developed by Google. Okay, and what does that do is when you have a lot of containers, right? I mean, you can have multiple containers, for example, and these containers can be managed automatically using the Kubernetes engine. So here we will talk about pods. Pods are nothing but your instances, for example, runtime instances. So you can have multiple pods, which can allow us to access the application. As an end user, you'll not feel what is the difference. These are self-managed, right? So kubectl is the function in Kubernetes, which allows us to manage all these pods. These are like multiple individual independent services which run instances, which run the same service. So if by mistake any pod is cancelled or has some issue, then Kubernetes is going to ensure that we have another pod made available. So you get the service as an end user, right? You don't need to really worry about any issue. So these are basically done in the nodes, right? It has storage, it can be scheduled, and it can also control all the resources that we have. And these Kubernetes engine is having load balancer, it contains storage options, it contains various cloud operations capabilities, and it also has restrictions, implementations, security implementations, basically using VPC networking as well. Right, so all these are the various services that are self-managed thanks to the GKE engine. So we will get our raw data. It could be from database. It could be any services. If I talk about GCP service, it could be a BigQuery, for example, very popular data warehousing platform in GCP. Your data is here. We establish a pipeline, and then we will try to use that particular data for machine learning model development. Data pre-processing happens, transforming happens, scaling happens, training on training data set, then doing hyper tuning using validation data set. Finally, you choose the best model using test data. We use hyperparameter tuning optimizations, etc., etc. And once the best model is defined, we save those best models and then we embed that using Flask code. Okay, this is basically what we have. Then what we do is we use the Docker software to create an image of all this particular code. Now, once this image is created in the Docker, it can reside in the image can reside in your local instance, but we can also try and push it on Hub, Docker Hub, which is global, right? Global repository for all the images. We can try and push this image onto the Hub. From Hub, using GCP services, we will try and register the image into the container registry. So GCP provides the container registry where we can try and register this image that we have just pushed into the public platform. And all that image goes into your registry. It registers that. And it creates a image on GCP container registry. Or you can say it is GCP Hub. This is an open source hub, and you'll basically try and connect here to take the image and place it in the GCP platform hub, right? From that container registry, once you have the image, you try to generate a service. So we will have to create a cluster, Kubernetes cluster. It can be self-managed, or you can have a basic cluster. And once we have cluster with multiple nodes, cluster means you will have not one service, not one computer, but you'll have multiple computers like this. Depending on the demand for the service, depending on the volume of the application that we are dealing with, depending on the load that the application is going to take from the customer, when customers request, the number of requests that are going to hit the particular service, you're going to define the number of nodes for your cluster. Right? Each node is like a separate instance computer. All right. And once the cluster is ready, the GKE is basically allowing us to create the images on these multiple nodes. So everything is automatically taken care. You don't have to worry about instantiating that image into a container runtime instance and then provide that application. Everything is automatically taken care. And as an end user, you'll only see the UI. And you will be able to access the functionality of your machine learning model. Right, so this is basically what we are going to do now. So let me take you to the hands-on. Right? We'll directly jump into the hands-on. Now, in order to work on this particular deployment, we need a GCP account to start with. I have that. Then we need to have a machine learning model. We need to have a Flask application, which embeds this particular code. You can say these two are together. Then we need to have Docker installed in our local machine. All you need is Docker software, which is again open source. Just install it. And once these are done, we can try and create image, push that image into the GKE, uh, Google Cloud Platform. You register it and then use the cluster, Kubernetes cluster, to deploy that image so that the end user can access it. So let us try and do this. These are the high-level steps. I have this simple code. We will try and use this. So to start with, I would be using, let's say, the prompt. Okay, this is our prompt. I also have the Docker desktop launched. Okay. Next, let us try and create a login. The first thing I would try and do is log into the Docker. So when you are basically creating an account on Docker, you should have Docker Hub account, right? You just try and log into the Docker Hub, right? And the same login credentials have to be given. If you're not logged in into your desktop here, if you're not logged into the desktop, then it will ask the username and password to be typed here. All right, so we'll have to do that. And once the login is done, the first thing is we will navigate to the folder where our code is placed. Let us go to the code. This is my, let's say this is the code that I have. You see the your machine learning model. Then along with this machine learning model, you have Flask application. And when you run this machine learning model, you will have the data pre-processing pipeline, and then the actual machine learning model, trained model, pickle file. Right? And then in order to create an image, okay, first of all, let me show you how it works on the local instance. So I will just navigate to this particular location. This is in the D drive. So I will just navigate to the D drive. Okay, this is the location. I would say Python space app.py. Strange. Okay, look at that. My instance is throwing this issue, right? So in my local, I'm not able to show you the execution. Okay, this is because the application that I'm using is in D drive, so it's not able to look into the Flask application. Nevertheless, not to worry, I would be showing how it works on our local Docker container. So what I'll do is I'll create the Docker instance, and then we will try and see how it works. So I've already created this image, so I'll just change this to GKE. Okay, I'll just change the name. I'll say GKE cars MLR. This is the command. This is going to create the Docker image in my local machine. Okay, you can see Docker space images. These are the images that I have. This is the image that I've just created. And I want to push this Docker image onto the Docker Hub. Push command is going to push the local image onto the publicly available Docker Hub. So I don't have that image, right? So I don't have that repository. When I push this particular image, it goes and sits into the repository. It creates a new repository and right, has that repository generated here. Okay, and let's see how does this work. It's refreshing. Just wait and see. Yeah, look at this. This is the image that we had just created. This is on my Docker Hub profile, and I'm making it public. Okay, you can also put restrictions. You can make it private as well. If you go into the image, you have all the settings. You can make it private, right? So you can simply say make private, so on and so forth. There are other options that you can just use in the Docker Hub. So I have pushed it onto my public platform. But remember, I said, how does it look if I execute it, right? So let us try and show you. The run-d is going to create a container runtime instance for this image. So here you can see, okay, let me, it's already stopped. So I have this image, right? The second image. This image is getting, it's already in use, but I don't have a container, right? So let me create a container here. And in this container, I'm using 5000 port and redirecting that same port onto the endpoint, right? So this is the container that I have created. Now you can see 11 seconds ago that this is the second container that I have generated just now. Okay, so you can basically see the details. Yeah. So I'll just click on this, and you will see this is our application, right? So I have a UI which basically takes in the input data and tries to give us the predicted output. For example, I'll use this and I'll pass the data set, a test data set or a new data set, and then I'll click submit and we will get the outcome. So this is mileage per gallon fuel is basically capturing using all these input fields. We also have non-numeric output, which is getting encoded. So that data pipeline is also embedded along with the code. Right? So this is basically how we can use the container image. So in my local, I was not able to show, right? Localhost, I was not able to get it. But when I use the Docker image, then it is taking all the dependencies that are required and we are able to use that application. Now, let us try and go through the next steps, which are basically to going into the GCP. So I have this GCP account already, and I logged in into it. The first thing is we need to create the project. In GCP, whenever we talk about GCP, we will have to have a project. You can create a new project by clicking on this and giving a name and creating the project. So every project is an individual entity which has its own billing, and it basically contains all the resources that are used specifically to get a application developed. So it can be mapped to a project or an end user requirements, and we can control the entire development using these projects concept. So I need to have a project. Always it has to be from project perspective. So I already have a project, so I'm using this project. Okay, and I would try and connect to the Cloud Shell, Google Cloud Shell, and this is available here at the right top corner, right? So the small arrow symbol in a square box is your Cloud Shell. I'll activate that. You can do a lot of things from the front end as well, but backend Cloud Shell will allow you to have more control, and we'll be doing the code executions. We'll try and balance, right? Certain things we will use it from front end, certain things we will do it from backend. I've already opened certain pages and I've done certain steps which are basically time consuming. I'll explain that theoretically, but let's proceed further with respect to the coding. Okay, this is the Cloud Shell, right? You can also take it to a new window. I'll keep it as is like this. The next is, once you're done with launch of your Cloud Shell, the first thing is you need to log in. So you can either type in or copy paste here a command into the Cloud Shell. In Cloud Shell, if you want to paste, copy is just selection, but if you want to paste, you have to say control plus you have to say shift, and then you have to use the button B. Okay, this is paste. So copy paste, right? So when you do this, you'll get the command pasted here. You cannot do just control V, doesn't work. Control shift V. So already we have credentials, right? So we are directly logging into the Docker from the shell using your whatever the login credentials are. And once we are logged in this particular account, we will try and pull this particular repository and the image, right? You can also tag it. You don't need to do this. I'll remove it, okay? That's optional. All I'll do is Control Shift V. You need to ensure that the repository name and the image name is correctly given, and then hit enter. So you can see we are trying to pull the image from Docker Hub public repository into this particular you can say the Docker the container hub in GCP, right? And it's going to take time. We have a big amount of file that needs to be copied into this. All right, so that is it's going to take its time. Then we need to have this services activated, authenticated. So whatever the Docker configuration that you want to do, you need to have those services authenticated here. So I'll be using this activate GCR command. I'll come here. It's still downloading. Once it's downloaded, we will be trying to activate the service. And this command that you're seeing here, right? This is to be done only once. Okay, you don't need to run it twice, multiple times. For one shell, one session, you do it only once. Done. Okay, so you have registered. Registry you are using. This is the specific registry, and we are basically having the credentials registered here. Next, we are going to try and get this image tag to the Docker repository. GCR is basically your Google container registry. We're trying to tag it. So I'll basically use GKE as the name. I'll do this. And this is the project. Every GCP transaction that we are doing is assigned with a project, right? So we are taking the project name and adding it here. So gcr.io / the project name / the application image name that you are trying to tag. So we are basically tagging the image that we have mapped from Docker Hub, Docker registry, right? So from there to here, we are trying to map it. Done. We have mapped. Now I'm going to try and push this. So I'm going to push this image into the Docker registry. But when you are trying to do that, ensure that the Docker container registry service is enabled. Any service you talk about in GCP is API based, and it has to be registered first. And to do that, You can come to the dashboard, for example, here. You need to search for your API and services. So I'll just click on this. And we are going to enable all the services that we have to use here. So predominantly, we are using two major services. One is the container registry. The other one is the Kubernetes engine. So you'll search for those. You need to click on enable APIs and services. It will redirect to this page. Here, you're going to search for container registry. So this is Google Container Registry API. If you click on this, it will take you to this page. Okay, this is your container registry. There you have images. The old image is already there. But now when I execute that code, it basically creates this another image. But first, we need to enable this service. Okay, ensure that when you click on it, it basically says the application API is disabled, enable it to use it. So you have to click on enable, because in this registry, I have already used the service previously. So I have the repository enabled, right? Google Container Registry enabled. So once it is enabled, we are going to come here and push that image into the container. So I'm executing it, right? So it basically says that you need to give access to that particular container registry and your image, basically. So Cloud Shell needs permission to use your credentials for the Google gcloud command, this particular command. I'll just authorize it. Okay, it has taken a while. So basically came out, and we're just trying to generate this repository. So we'll try and click on this. You can see this is the image that we have created. So if I click on it, you'll see this is the image. Right? So this is basically the details of your Docker. This is the command that we have executed just now. Right? If you want to pull, you can also do this. So we have done the push, not pull, but we have pushed the image that we already have into the registry. Then these are to ensure that we set the details for your gcloud shell. So I'll go back to the G shell and I will execute this. Okay, so I'm just registering the project as well as the zone. I'm in India, Asia region, and we are saying Southeast 1A. Depending on where you reside, you can also use these zones. Okay, and this is specifically used to create your cluster. You either do it here from the backend like this, or you can go to the Kubernetes engine. So you need to go to the Kubernetes engine, which is navigated from the compute section of your Google dashboard. And then you have clusters section. And this service that we're talking about has to be first enabled. So let me show you. So again, if I click on here, you see the compute section. Under compute section, you have Kubernetes engine, right? So you need to basically click on this clusters and then go to the clusters page. This clusters page, it is basically disabled to start with. You need to first enable it. And then you can create cluster either from this UI by clicking on that create button. When you do that, you have two different options. Autopilot is basically like auto ML, auto managed GKE. It is recommended, but it requires a lot of right, billing and all that. It's a little heavy on pocket because of self-management. We are going to go with the standard. So here we are going to use create, and here the function is auto create. Right, this is auto create function. If I remove this, then it is creation of a cluster with 2 nodes. Right, so you can also create it by clicking on configure here. Right, and you can give a name, choose the region, zone, all these things, and then just create the instance clusters. Okay. Right. I'm not doing this. If you can see the command line code, this is basically the code, and I'm basically saying this part. You don't need to give all the other parameters. You can just restrict your execution to this. Okay. So I have executed this, and I already have the cluster. This is going to be a time-consuming activity. So I'm using already existing cluster. I'm not using this. Right, this is the cluster that I already have with 2 nodes. Okay. Next, once the cluster is created, we are going to get the credentials. And to get the credentials, we are going to run this command. You can say cluster get credentials MLR cluster zone and the project name. And once it is obtained, the cluster credentials are obtained, you can run your deployment code using kubectl. All right. Now, either you run it from this backend, or once the deployment is done, you can also expose it so that you get front-end. What I will do is, rather than executing this, I will show you how we can do it from front-end. So I'll click on deploy button here. And we are using existing container image, right? So I'll click on select. Here it will give us the list of images. This is the image that we just have created. So I'm going to use this GKE cars MLR image. And I don't have any environment variables. I'll not use them. I'll just say done. And then I'll say continue. This is the container. If you want to add another container, you can do that. I'll say continue. You give an application name, your version. So I'll say GKE app. Right? And namespace is default. You can ignore that. And this is app and GKE app. It is the labels will automatically get written. And for Kubernetes, we need to have this YAML file generated, and this YAML file is automatically generated. We don't have to do anything. If you're doing a local instance of Kubernetes, right? Locally managed Kubernetes engine is there, then you'll have to create this YAML file. Again, this is like your configuration file, which allows the Kubernetes engine to manage all the services that we have in the cluster for running this application. Okay, so I'll just choose the cluster. I don't have another cluster. I have a single cluster, so I'm choosing that. If you want to create a new cluster, you can just directly create it from here, or you can go to the cluster page and then create. That's all. You say deploy, and this application is getting deployed. So this action that we have done is done automatically using this command. You can give an application name and then the image name. The image name that we have used here is this one. So I'm going to use this image name. You can give a new image name, right? Okay. Done. Set up an automated pipeline for this workload. If you want, you can set up it. And I can ignore that pipeline is not required. Now, in order to use this service, we need to expose it. To let others access your deployment, you need to expose it. right? And when you say expose, it creates a service. Either you click here or click here. So it basically says, okay, internally the port number is 80. What would be the target port number? I would use the default 5000. I will be using the service type, which is load balancer. And the service name is GKE app-service. You can give any name here. You can ignore the default service name as well. And then say expose. This expose command is the 12th command here. Right? And once this is done, you would get external IP. And you can also see this external IP by running the service in your cloud check like this. So kubectl gets services. The external IP is not generated. Right? The service is not yet exposed. We're using GKE app service, right? So it is not exposed. We can also track it here. Under workloads, you will see that the application is getting exposed. Right? This is done. That's all. Very simple. Okay. Now, this is the external endpoint. Now, if I click on this, it is going to give us the UI. Right? All the Flask code and the templates are being used, and you just pass the input data, the new data that you want to pass as the input for prediction, and then click submit. Voila. So you have a machine learning functionality provided as a service to end users using UI, right? And that UI is created with Flask application. Very simple. The most important thing that you need to ensure you have is your machine learning code, your Flask code, right? And this ML code is basically developed using pipelines. So you have saved models which are embedded along with Flask code. Then you can use Docker and then Dockerize it. That is, you generate an image and a container. So first we'll create an image, and then we will try and have this image pushed into hub, right? And from the hub, we are going to use GCP. In GCP, again, you will have a local Docker instance, right? Local repository. So in GCP repository, you're going to map the image, right? And register this image in the container registry. And once this image is registered, in order to ensure that this image is deployed, you need to have service, right? Hardware. This hardware is created using GKE Kubernetes Engine. So we will have a cluster. Depending on your requirements, you're going to develop the different size of clusters. And then you deploy the application on this hardware, on the cluster. And once the deployment is done, you're going to expose the application on a specific port so that it can be accessed by external port, right? And you'll get external URL, and you can use that for using the application. And depending on your end users, the demand for the application, the GKE is automatically doing the load balance of the requests. All right, so this is basically how we do our deployment. And I hope you have enjoyed the session. And as you can see, it is very, very, very easy in order to do the deployment. Right? And Voila. So that's all about your deployment of machine learning models on Google Cloud Platform. Hope you have enjoyed the session, friends. And in the next session, we will try and come up with a different tool, which is basically used for deployment. And as and how we proceed into the series, we are trying to bring in more and more aspects that are required or that are to be considered when you are trying to do the deployment. Especially from machine learning operations perspective, we need to have CI/CD implemented so that the application that you are developing is always having the training also considered. So it is like continuous training that we need to focus on. So in next session, we will talk more about these concepts and we will try and see how the maintenance and tracking is happening. So hope you have enjoyed the session. Thank you so much for attending the session and we'll see you soon. Thank you. Enjoy the rest of the day or rest of the evening.